Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're joining me live or you are watching the recording later on. Thank you for watching. Always appreciate that. Before we get started today, just a couple of announcements. Remember that your Module 3 assignments are due tonight by 11:59 p.m. or midnight, whichever you want to call it. We're going to be talking about Module 4 today, remember, because we're always a week ahead when we do these live streams. So Module 4 starts tomorrow, but Module 3's assignments are due today. And so I also just wanted to point out one thing, because I think I pointed it out previously, but several different classes, and they all kind of run together. So before we get started, we do have a lot to cover. I just wanted to point out tutor.com again, if I haven't already. Great place to go to get some extra help. And I will, kind of add something to this here, right? You can choose your topic, which is going to be information technology. You can choose your subject, which is going to be CIS 115, Python programming. And when you ask your question here, I'm going to add something to this, that you should be as specific as possible when asking your question, right? Because these are assignments that are kind of geared toward allowing you to solve problems with the tools that you have currently. So for example, with Module 4, we use recursion, and you have a pretty, a larger kind of assignment there to do with recursion. And so if you were to use this and ask them, for tutoring help here, it would be important for you to include that you have to use recursion to do it or whatever, right? So, because there are other ways outside of recursion to be able to do the recursive things that we're doing in Module 4. So that is, just something to bring up and something that I wanted to bring to all of your attention as we're getting, before we get started today. So there is that. But we're starting Module 4 today, and Module 4 is about conditionals and recursion. And in an effort to kind of keep this a little short, I'm going to kind of go through this relatively quickly. Right? I want to spend more time on recursion, and I want to spend more time on the main gate, if at all possible, right? So we're going to kind of breeze through conditionals as we get started here today. If you need some additional material, some additional help with these, just let me know, and I can definitely provide those. But the first thing that we need to ask ourselves is the question of what is a conditional? Just what exactly is a conditional? And so sometimes we want our programs to be able to make decisions, right? That's the big key point of working with conditionals, right? We give our computer the option to make decisions. So far, as we've done flow of execution, everything's just been done, kind of top to bottom, right? We kind of topsy-turvied it just a little bit with our idea of functions in Module 3, because we can call different functions in different orders, but the flow of execution is still relatively standard, right? Top to bottom. With our conditionals, this is really the first time we're doing anything to kind of break our flow of execution, to change our program from being what it is, which is basically just running everything in order from top to bottom, to something where we branch off and we have different paths for our program to take based on conditions. So we use our conditionals to conduct this decision-making process. And so as we're talking about conditional execution here, we're talking about an if statement, right? And our if statements have a condition. And what you see here with our syntax is sort of pseudocode. We'll do the actual code in just a minute, right? In our replit. but we have some condition. And this condition is like one of those proposition statements that we looked at earlier on in one of our earlier logic-based discussion boards, right? A condition is going to be something that evaluates to either true or false, right? No ambiguity there. It's either going to be true or false. And, that's going to be the condition on which some other code is run. And so if that condition evaluates to true, then the code that belongs to that condition, right? Like if you remember back to last week, we said one of the things about that shouldn't have happened. But it's good enough. We said one of the things that goodness. We said one of the big things about these statements that have these colons at the end of them is that means that something else, more code, belongs to them, right? There's more code that's a part of this. And we put that indentation on the code that's a part of the statement that has the colon after it, so we can show that ownership. So we can show that relationship between these lines of code that are either part of a function, part of a condition, part of a loop, so on and so forth, right? So our if condition here has this colon at the end of it. So that means there are more lines of code that belong to it. If that condition comes back true, then we are going to run these lines of code that belong to this conditional statement. If it comes back as false, then we do not run these extra lines of code that belong to this statement. We just skip right over them and go on to the next thing. And so we have to have at least one statement inside of each branch. So if we have an if statement, we have to have at least one condition. We have to have at least one little statement that inside of that if condition. We can't just leave it empty, right? There has to be something in there that it will do if this condition is true. And we can chain our conditionals, right? So if we look at a chained conditional, for example, I'm not sure why it keeps doing that. We can have multiple statements that it's checking. So if this is true, then it'll run the code that belongs to this. Otherwise, it'll skip it and run the code that belongs to this, so on and so forth, until it finds one that's true. Or we can have nested conditionals, which are subconditions. And with these subconditions, we can have conditions inside of conditions. So we can say, well, if this one condition is true, then we can check this other condition. So let's write a couple conditional-based expressions here so that we can see how these work and we can work with them. Let me just pull up my replit here. Here we are. We'll switch over to our full screen here. And we'll go ahead and we'll zoom in here so we can start writing some code. So I'm going to start out by writing my shebang. So that's hashbang /USR/bin /env Python 3. And let's write some functions here, shall we? So we're going to write, and actually, you know what I want to do? I want to make a new file here. I'm going to make a new file. This is something that you're not going to have to do for any of your assignments, but I'm going to need it to be able to show off the main gate later. So I'm going to make a new file here, and I'm going to call it conditions.py, and this is where we're going to put our conditionals. Now, if you do choose to make a new file, you can, right? And you can choose to separate your functions from your code and all that other kind of fun stuff. If you're testing your conditions.py file, you have to run it in a bit of a different way, which we'll look at in just a minute. So we'll add our shebang in here, hashbang /USR/bin /env Python 3. And now we can write our conditions, functions for our conditions. right? So the first thing that we'll do is we'll write a function. So we'll define a function, and we'll call it simple condition. So this is going to be our most basic condition. Let's pass in some kind of numerical value via our arguments here. So if you remember back to last week when we were talking about that pneumatic tube, right, that allows us to take data from outside of our function and bring data into our function. That's what this, that's our argument here. And so we're going to check to see if our number value is greater than 10. Right, so if our number value is greater than 10, we're going to do something. Right, and so this is a condition. This is, similar to those propositions we talked about earlier in the course. It's not ambiguous, right? When we bring our value into our program via our argument here, it will, have a value in there. That value will either be true or false based on whether or not the number we bring in is less than or greater than 10. And it'll, give us some code happen. So we'll just print a statement here in this event, and we'll print greater than 10. So just a little simple number evaluation here. Right? And so this is our most simple form of a condition that we can write, right? We have our if statement. If being the start of our condition. We have some sort of conditional case that we can check that will evaluate to either be true or false. And then we have the lines of code that belong to this condition that run in the event that this condition is true. So if this condition is true, this code will run. If not, this code will be skipped. So let's invoke this function and see what happens from here, right? So I'm going to invoke simple condition, and I'm going to invoke it with a value 13 as my argument. So hypothetically, right, this will take that 13, put it into the num place. 13 is greater than 10. So we should get greater than 10 printed out to our console. Now, if you're doing like I'm doing here, right, you're writing this in another file, Replic's a little weird about this. Right, because if I click the run button here, the run button only runs the main file or the main.py file. It doesn't run any additional .py files that you might create. It only runs the main one. So in order to run one of the additional ones, we have to go into our shell tab over here and type in Python and then the name of the file, conditions.py. And then we can see it run. Now we get greater than 10, right? And that's what we would expect because that number is in fact greater than 10. Now, if we were to come in here and we were to change this number to something that would make that condition false, and then we ran this program again, you see that we get nothing at all. Right? We get absolutely nothing at all in that case. Because since that condition evaluated to false, it just skipped this. So you might think, well, what if I have more things to check, right? Like what if I want to check more stuff instead of just, checking this one thing? And so for that, we have chained conditionals and we have nested conditionals. So let's write ourselves a couple more functions. I'm going to just hit enter a few times here to kind of push that down a little bit. And I'm going to write another function for chained conditionals. And we'll still bring in a num value. So for a chained condition, I was referring to it earlier as kind of like the exits on a highway. Right? You get a highway, and on this highway you have multiple opportunities to turn off to try to get to your destination. Right? And that's kind of what our chain conditional is doing here. We start off on the starting path. That's going to be our base condition. Right? So we're going to have an if statement here as well. But if this if statement is not going to get us to where we want to go, if this if statement is false, we have other options to pick a path based on these other conditions. Right? And this is going to be either an L if or else if, which we can kind of think about that as or else if, right? If this, or else if this, or else if this. So we can have as many elifs as we want. And then if we just want a catch-all at the end that basically just says, well, everything else we want to do this other thing with, we can write an else condition. And our else condition is going to be like a catch-all. So if we were drawing this as kind of a tree diagram here, we kind of draw it like this, right? So we start out with one condition or one program, and then based on whether or not that condition is true, we get all these other options of different paths to take based on how many if or else if conditions we have, right? So in this case, I'm going to want to start off with a singular if condition. And so we'll use the same one. If num is greater than 10. We'll print greater than 10. And we can add another condition here to where, if it's not greater than 10, but it is, a number that exists, we can add an elif condition here. Elif, number maybe greater than 5. Print greater than 5. Now, one of the things to note here, right, is that since we evaluated this condition first of whether or not num is greater than 10, if this is true, it's going to skip everything else, right? Think about those, think about those exits again, right? If you can get there from the highway, you don't need to take an exit. You're just going to keep on going straight. If you need to take an exit to get to where you're going, you're going to take one of these LF exits and start going down that path. Right? So if you don't need one of these LFs, you're going to skip that LF. Your program's going to skip that LF. So if our number starts out by being evaluated greater than 10, then that means it's going to be greater than 10. So that's anything from 11 to infinity. And it's going to print greater than 10, and then it's going to skip out of this conditional block. It's going to be done. Right? So we can assume then that based on this, we know that this number here, because otherwise if it was 11 to infinity, it would have triggered that first if condition, that this number here is between 5 and 11. And we could write another elif condition if we wanted to, right? Elif num greater than 0. Right? So in this case, right, we see that this is greater than 0 and less than 6. Right? Because the number that we get from our first elif statement has to be between 6 and 10. So the number that we get from this second elif statement has to be between 1 and 5. Right? So this is between 11 and infinity. This is between 6 and 10. My mouse is going crazy. This is between 1 and 5. And so if we want to include all other conditions in a conditional statement, we can add an else statement here. And so with our else statement, we don't include a proposition, right? There is no proposition or condition that we include with this else statement. Because when we are saying else, what we are saying there is all other conditions. If any of these other things that came before this is false, we're going to run this instead, right? So in this case, this is going to cover every number from 0 to negative infinity. So we're going to print this number is, we're going to print 0 or less to try to follow our pattern here. Because this number is going to fall between 0 and negative infinity. Right? So if we were to invoke this function, we can invoke it with different values, and we can see our program take the different exits based on what that value is, right? So we can take the change condition path, and we can start off by passing it a big value like 11, right? We know that that will get off at the if statement. So we should be able to run this with our Python conditions.py command in our shell, and we get greater than 10, right? As we would expect. If we change this to be something like 7, then that's going to come back false on this one, but it's going to come back true on this second one here, right? So it should take its exit right here on this first elif. And so we can run that and just see what happens there. Greater than 5 and less than 11. Right, so we can see our program take the different exits as we enter the different values here. Right, and so if we went for a number like 4 here, that's going to evaluate false here, that's going to evaluate false here, but that's going to evaluate true here. Right, so we can watch this take another exit, greater than 0 and less than 6. And finally, if we enter something like negative 4, that's going to be false here, it's going to be false here, it's going to be false here. So it's going to fall into our catch-all, which is our else statement. So we can say that this is 0 or less. And so we see that work, and we see our program kind of take these different exits based on the elif that is true at that given time. So that's a chained conditional. Now let me just comment out both of these invocations here. We'll just do a quick little comment out. And we'll do that. And now we'll write a nested condition. So we'll define a new function for a nested condition. And we'll take in a value of a number here. And so with our nested condition, what we're asking our program to do is make another decision after it's already made a decision, right? We're putting a decision-making path inside of another decision-making path, right? And so if we can kind of think about that in terms of like trees and such, you know, we look at a standard condition-making path here, where you can take either one decision or the other. So if this other decision is true, we're going to look at another decision based on that, right? We can tree this on down. Like we can go as deep as we'd like to go with nested conditions. And these nested conditions are only going to run if that first condition is true. So we can look at it in this sort of way, right? So I'm going to tab over to be inside my function. I'm going to write an if statement here and say if num is greater than 10. So if num is greater than 10, if the number that we pass in here is going to evaluate to 10, then that's going to be true, right? So it evaluates that statement and it says it's true. But then we could also put another statement in here inside of this if statement, nested in this if statement, and say if num is less than 50. Right? So this is only going to happen to begin with if the number is greater than 10. And if that number is greater than 10, it's going to check another condition. First, it's going to see if it's less than 50. So if it's less than 50, I want to do something. If it's more than 50, I want to do something. So I can say, well, if num is less than 50, I can print greater than 10, less than 50. Right, so that's going to cover the numbers between 11 and 49. Right? That's going to cover the numbers for us between 11 and 49. So if we want to cover the rest of the numbers that are possible to be covered in this condition, we can just put an else statement in here and print greater. We can actually print 50 or greater, because that's going to cover all the numbers that aren't covered by this. So if the number is greater than 10, so it has to be greater than 10 to start out with to run these conditions, or to check these conditions. We're going to see if number is less than 50. If it's between 10 and 50, then that causes this to trigger. If it is greater than 10 and greater than 50, basically, in terms of the logic that we have here, it's going to print 50 or greater. This is a nested condition. And so we could also tab back out, so hit our backspace key, get out of the tabbing, to include an else statement that is paired with that initial if statement. And so this number here would be 10 or less. Right, so what we have here is a nested conditional. We have a conditional inside of another conditional. So where this gets kind of tricky, and it's going to be based on the problem that you're solving, where this gets kind of tricky is deciding where I need to check my conditions, how I need to check my conditions, and in what order I need to check my conditions. Right? Because when you're checking your conditions, as we've seen here, once you take an exit, you're off that road, right? Once one of these statements evaluates true, you can't go back and try to evaluate that number again. It's going to run the code that's associated with the true statement, and that's going to be it. It's going to move on to the next thing. Right, so what we want to do here is we want to make sure that our conditions are being evaluated in order where they all have the possibility of being checked based on a given value. Right? Because let's say if we had these two flipped here, right? Let's say if we looked at our chain condition, we had these first one and second one flipped to where if num is greater than 5, it does one thing, and if num is greater than 10, it does another thing. Right? Well, whenever it hits that num is greater than 5, it doesn't matter what the number is, right? If it's 20, if it's 30, if it's 100, if it's 1,000, all that's greater than 5. So it's going to hit that if statement. That if statement is going to evaluate to true. And that's going to run and it's going to stop. So it would never actually reach, if we swapped those first if and elif statements, it would never actually reach that first elif statement because everything that was bigger than 5 would be evaluated on that first if statement. Which is crucial, right? Like, this is important for us to realize, and it's important for us to, as we're thinking about problems and such, to try to think about what we need to check first versus what we need to check later. So typically it's kind of a good idea that if you're going to be checking greater than, you start with the bigger thing you want to be checking first. If you're going to be checking something to be equal to something else, you would always want to check that to be before anything is greater than or less than, right? So that's just something to kind of think about as we're approaching this problem. Well, we can run this nested condition now. So it's only going to run the nested condition in the event that that primary condition is true. Yeah, so we can invoke our nested condition. We can start out with a lower number like 6. And we can run the program here. We get 10 or less. Right, if we enter something like 20, we should trigger this condition true, which would in turn trigger this condition true and give us greater than 10, less than 50, which we get there. And if we made it even bigger, say 60, we should get 50 or greater, which is perfect, right? That's exactly what we're expecting here. That's good, right? That's what we want. Now let's take a bit of a side road. Because we have recursion to talk about. We need to talk about recursion. But before we talk about recursion, I think I want to switch this up a little bit and talk about the main gate. So I'm going to put a pin in this conversation for a minute. And I'm going to switch over to this one, which is the main gate. Because now we have an extra file that has some functions in it that do something. Right? We have a file with extra functions that are invoked. So let's talk about the main gate. And the main gate, the code for the main gate is what you see here. If underscore underscore name underscore underscore equals in quotes underscore underscore main underscore underscore and then a colon. So what does this do? So before executing code, the Python interpreter kind of reads our source files and defines a few special global variables. And one of them is that underscore underscore name underscore underscore. So if the file being ran, if the file that is being executed or let me rephrase this. The file that you are running is always main. It's always that quote underscore underscore main underscore underscore quote. The file that you're running gets given that value as its underscore underscore name underscore underscore every single time you run a file. If you're using an external file, to house some functions that maybe you wrote for another project and you want to import them into this project, then you want to make sure that what's running in that other project does not run. You only want the things that are supposed to be run as a part of that project, as a part of that particular script, to be run. And that's what the main gate is for. It's to inhibit function. Let me show you what happens. So now that we have this file here, and I have these functions here invoked, right? I'm going to change this one to be something that will run for the purpose of this. So there's no main gate in here, but I do have some functions in here that I've written that I might want to reuse elsewhere. And I have some invocations of these functions that are used for this program. Let me switch over here to my main gate. So if I want to import that file, I can import that file. I can import conditions. And that's going to import conditions. It's going to import this other file into this new file. And so with this, I can use the functions from this file, from this conditions.py file, in my main.py file without having to rewrite them. What I also might want to do here is define an alias for this other file. So, I don't have to type conditions out every time I want to reference a function in the other file. So I'm going to import it. I'm going to import conditions as C. I'm going to give it the alias of C. So now I can reference the conditions file as C. So if I want to invoke a function in here, I can invoke, say, nested condition with a particular number. So that would be in the C or conditions file, dot, run the nested condition function, and I can pass it an argument, right? You can see there, right? I get this tooltip from my IDE is it understands because I imported that file in here properly. So I'm going to run 56 here. But I want you to watch what happens on the console when I run this. I can run this with the run button now because I'm in the main.py file again, right? So I want you to watch what happens here when I run this function. I get greater than 10, 0 or less, 50 or greater, 50 or greater. Why does that happen? I only have one thing invoked here, right? When we import a file, we import everything from that file, right? So all of the code that we wrote here, including these invoked functions, gets imported into here. So part of running this program also involves these functions executing. Now, we don't necessarily want to do that, right? We want to be able to stop them from doing that. So in order to do that, we lock them behind the main gate. We have to lock them behind the main gate. And the main gate statement itself is just a conditional statement, right? Starts with the word if. If underscore underscore name underscore underscore equals equals, and then in quotes underscore underscore main underscore underscore. Since these are a part of a conditional statement now, we need to tab them underneath to show that they're a part of that statement. Right, so now these are locked behind the gate. So they're only going to execute in the event that the file that is being executed is the conditions.py file. So only if we're executing the conditions.py file directly will these functions run. If I go back here to my main Python file here and run that, we see now I only get 50 or greater because those others are locked behind the main gate. And if we go and we run that conditions.py file, those three functions that we invoked still run because they're a part of that function. So just to kind of lock the code that runs versus the modular code like your functions that you can use in other programs, we take basically everything that's not a function and put it behind the main gate. So even in this code here, we could write if underscore underscore name underscore underscore equals equals main and now that call is locked behind the main gate. Right, which in this case is a little bit redundant because like all we're doing here is just using functions from that other file. Right, but this is still going to run in our console if we run that, right? That's not blocking it from running as long as main.py is the one that's running. And if we were to bring main.py here into something else, then it would import everything and it would ignore that part. Right, so the big takeaways out of this is essentially that we want to, the file that's being executed, the file that's being ran, is always main. Any other file is that file. Right, so in this case, the main.py is being ran, so it gets the name of main. Our conditions file gets the name of condition. So we get to say import conditions. So in this case, main.py is main, conditions is conditions. In this case, when we're running this file directly, conditions.py is main, but only when we're running conditions.py directly, like we're doing here to get the output in our console. So now that we know that, and we know basically how that works, we know that basically our main gate is something to just kind of separate the functions of our program to the things that execute those functions, the invocations of the functions, the inputs, and all the other kind of stuff. We're just separating the functions from the stuff that's actually executing. So now that we know that, we can include this in every program that we write, and you should include this in every program you write. I will be expecting you to do this. And we can see this working now. And so we can kind of leave the main gate at that. I know you also have some information on that in your module, but hopefully that helped clear it up for you all. Right, we don't have to use more than one function to use a main gate, or we don't have to use more than one file rather to use a main gate. We can only use we can only just use one file and still have the main gate in there and it'll be just fine. Right, but we have to have the main gate and the file. I'm going to be expecting it. So now let's go back and talk about recursion. Well, Do I want to write the program or do I want to just talk about recursion? Let's write a program. And I'm going to do it in another file here. We'll try to keep all this isolated. Because I want you all to see leap year dot py. And we'll do everything here. We'll do the main gate and we'll do all our conditionals and everything. And we'll run it using our shell since it's not the main file. I want to do this program for determining a leap year. So we see some steps here. If we were a little less pressed for time, I would kind of draw these out and kind of show you the different paths to follow. If you are, watching the recording here, especially, what I would encourage you to do is to pause the video here and see if you can write a program that would do what we're about to talk about here with determining a leap year. Essentially, we have these conditions that we need to check to see if a leap year is a leap year or not a leap year. So what we want to do is we want to take an input from a user. We want to pass it into a function. In that function, we're going to run some chained and or nested conditions, depending on the situation. These are primarily going to be nested because we can see, like, if the year is evenly divisible by 4, we can go to step 2. Otherwise, we can go to step 5, so on and so forth. So if the year is evenly divisible by 100, we're going to go to step 3. Otherwise, we're going to go to step 4. If the year is evenly divisible by 400, we're going to go to step 4. Otherwise, go to step 5. And these step 4s and 5s. 4 is that it is a leap year. 5 is that it's not a leap year. So as you're watching this, just, you can kind of pause here if you want, give this a try, then come back. And we will, I'll go ahead and do this program now. So in this new file, here our leap year.py file, I'm going to add my shebang, hashbang, user bin, environment, Python 3. And I'm going to create this function. This function is going to be called defined leap. And it's going to take some year value, right? The year value is going to be the argument. We're going to pass the year value through invocation. And so the first thing is that if the year is evenly divisible by 4, then we're going to continue on and go to step 2. Otherwise, we're going to go to step 5, which is to say it's not a leap year, right? It has to be divisible by 4 to be a leap year. So we're going to say if year modulo 4 equals 0, then we can continue that. Or the other option would be to kind of flip the logic there and to say if year modulo 4 greater than 0. So if year modulo 4 is greater than 0, that means that 4 does not go into 0 evenly. So we can go ahead and print not a leap year and continue on with an else condition. And so in our else condition here, or we could do an elif, right? We can approach this differently. We can chain or nest them. Right? So let's do an elif here. Actually, no, you know what? We need to nest these, or else we're going to run into that problem I was talking about earlier, where if the previous thing evaluates to true, and then it's going to stop running, right? So we're going to need to do this. So we know that if it's not evenly divisible by 4, then under no circumstances is it a leap year, so we can say that. Else, we're going to do another if statement. And the next one is, if the year is evenly divisible by 100, we're going to go to step 3. And step 3 is checking to see if it is evenly divisible by 4. Otherwise, we're going to check to see if it's evenly divisible. Otherwise, it's going to be a leap year. Right? So, yeah. Get a little tongue-tied here toward the end of the day. We're going to check to see if the year is evenly divisible by 4. If it is, we have another check to make. If it's not, then we can say that it is definitively a leap year. Right? And I looked up this algorithm. Don't think that I'm clever enough to come up with this algorithm by myself. I looked up the steps to solve this problem, and now I'm just showing you how to code it. Right, so we can look at the logic in the same way here. So we can say if year modulo 100 is greater than 0. So if the year is, so this, in this case, right, the year would have to be evenly divisible by 4, but not evenly divisible by 100. And we can print this is a leap year. Else, we're going to check one more condition. And that condition is whether or not it's evenly divisible by 400. So if it is evenly divisible by 400, then it is a leap year. If it's not evenly divisible by 400, then it's not a leap year. Right? So we can say if year modulo 400 is 0 equals 0, then we can print this is a leap year. Otherwise, we're going to print not a leap year. And so as you can probably see here, like one of the toughest things about this is determining like what order you need to put your conditions in to make sure they're satisfied in the proper order. So that's why I recommend to sit down with just a pencil and a piece of paper, or a pen and a piece of paper before you get started, and just trying to write everything out and map it all out and try to see if there's any issues with what you think you need to do to solve your problem before trying to get into the code. So let's, that's a pretty simple algorithm. So let's invoke it. Let's do it properly, right? So in this case, I want to put this behind the main gate, what I'm about to write. So if underscore underscore name underscore underscore equals underscore underscore main underscore underscore colon. In that case, right, if this is the file that we're running, we want to ask our user to enter a year. So we're going to set maybe value y equal to input. Actually, we'll need to typecast the integer value of the input of enter a year. And then we can invoke our find leap function with the value y as the argument. And so we can type here Python leap year.py. I typoed my name over here. I called it learyear.py, so let's change that to leapyear.py. It's going to tell me to enter a year. For example, I know this year is not a leap year, so I should be able to enter this year, 2022. Hit enter, and I get told that it's not a leap year. I believe the last leap year was... When was it? I don't think last year was a leap year. No, I think the last leap year was 2020, right? So we can run this program, enter the year 2020, and that should tell us that that is, in fact, a leap year. And we can pick any year throughout time, in the past or in the future, and we can run it against this algorithm. You know, like, what was 1976 a leap year? Yes, it was. Will 2438 be a leap year if everything's not melted by then? No, it will not. Right, so that's how we do this. So that's a complete program there that uses chained and nested if statements along with our main gate to find out whether something is or is not a leap year. Which is pretty great, right? Makes a lot of sense, I think, anyway. So with that being said, let's talk briefly-ish about recursion. What is recursion? So we can basically take problems in any area of life and we can define them recursively, right? And when we're talking about defining a problem recursively, we're talking about defining a problem in relation to itself. Right, so we're talking about defining a problem in relation to itself. So like if we think about like a compound sentence and we think about the definition of a compound sentence, that's two sentences with and between them. Right, so a compound sentence is two sentences. So the definition of a compound sentence is more sentences, right? Like it's recursive to itself. We have the word sentence in the definition of a compound sentence. You know, we can kind of think about it as like two mirrors reflecting itself, you know, kind of infinitely. Right? Anything, you know, pretty much anything that we can write recursively, we can also write iteratively. But I start with recursion because, you know, there are some problems that we can kind of only solve recursively. Recursion's good for you to know. It's it's one of the key tenets of making a program Turing complete. So it's important for you to know this topic. But it's, basically the first way that we can kind of get our program to loop over itself so we don't have to write out the same code multiple times. Now, we do have 3 laws of recursion. One is that there must be a base case. So we need some kind of conditional statement that can start out as true, that we can later make false, right? Because we need to be able to kind of turn on and off this recursive call. There must be a recursive case, which is a line of code that calls the function from within the function. So we're calling a function inside of itself. So when it hits that function call, it's going to jump back up to the top of the function and start running that same function again. And your recursive function call has to iterate. It has to move the problem that is the base case from the state that makes it true to eventually get it to the state that makes it false. And you can kind of think about it as like taking a step. Right? So you can kind of look at this as, this condition where I'm saying, I'm going to take 10 steps and stop. And so maybe you're going to say, I'm going to take 10 steps and I'm going to shout out the number of steps that I'm on, and then I'm going to stop. So I'm going to take a step and go 1, take a step, 2, take a step, 3, take a step, 4, take a step, 5, right? We're having to increment that value so that eventually we get to that point where we want to stop taking steps, right? That's what we're doing here. If we don't do that, we're going to end up in an infinite loop. An infinite loop is where something just kind of keeps going over and over and over and over forever. We don't want that. Right? In Python, we have a little, we have a little built-in call stack check that kind of determines whether or not the call stack is getting out of control, and it goes ahead and halts our program for us. So it actually stops our program before it runs out of memory. But other programming languages don't have that. So if we're going to use this same sort of thing in another programming language, we need to be clear that we're doing the right thing there. So let's just do an example of that, and hopefully that'll be a little clearer to you. All right, I'm just going to make another new file in here, and we'll call this recurse.py. And we'll add our shebang in here. So let's say we wanted to count to 10. Right? And from what we know so far, what we would do is we would say print 1, print 2, print 3, print 4. Right? But that breaks our dry rules. Like, you remember a few weeks ago we talked about dry. Dry standing for don't repeat yourself. Right? We want to repeat ourselves as little as possible. So let's make a function here. We're gonna make this function. And we're going to call this function count. And we're going to pass it some number. And we're going to say if number is less than some endpoint. So let's say is less than or equal to 10. So we'll start out by counting to 10. But we could also get this. We could also kind of flip this. So you know what? Let's do that instead. Let's have number be the number that we want to count to. And let's compare that against a starting point. So we're going to create a start and number variables here. So we're going to bring in a starting point and we're going to bring in an ending point. So we can even just call this end. So we're going to say if start is less than or equal to end, then we're going to print start. We are going to increment the value of start. So we're going to say start plus equals 1. And then we are going to, or actually, just to make this more clear as to what we're doing, we'll just do this in the recursive call. We'll call this function again, count. In our count invocation here, we'll add 1 to the value of start. So start will equal start plus 1. And end will stay the same. So each time here, we're going to be progressively getting closer and closer and closer to the end value, right? Because the end value is staying the same. The start value is increasing. So eventually, we're going to break that condition that we wrote there. We're going to break that condition that says if start is less than or equal to end. And so once start becomes higher than our ending number, it's not going to run this code anymore. It's going to stop. It's going to be done. Right? So what we could do here, right, is we could put a little ending message, right? So we could add a little else clause here and say, print thank you. Or we could just let it trail off and stop and just not print anything afterwards, right? We could do either one of these here. So now behind our main gate, we're going to do our function call. So we're going to say if underscore underscore name underscore underscore equals in quotes underscore underscore main underscore underscore colon. We're going to declare our, we're going to add an input here. So we're going to say e equals the integer typecast value of input. Enter a number to count to. And then we will invoke count with our starting value of 1 and our ending value of E, which would be the value that our user enters in. So now we can count from 1 to E. We run Python recurse.py. It's going to tell us enter a number to count to. Let's start out by counting to 10. And we see we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then thank you. Right? We can do anything we want with these values. Right? We can nest conditionals in here and say, oh, if this number meets this condition, right? Like we can say, if start equals 3, print bleep, and restart our function count. Or actually, we wouldn't necessarily want to do that. And else print start. And we can just leave that function invocation there on the outside of the if statement. So it's still a part of the if statement, but it's not a part of this nested if. So it's going to either do this or this, and then recurse the function until that start number becomes bigger than that end number. Right? So let's remember to go into the shell and do that. Clear my shell out here. We'll run Python recurse.py. Enter a number to count to. Let's count to 13 this time, just to show we can count to any number. And ideally, if the number is 3, instead of having the number 3 there, it's going to say bleep. And there we go, right? That shows us we can do whatever we want with these numbers. So we get 1, 2, bleep, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? So the big thing with our recursive invocation, using recursive methods here, is that we have a starting point and an ending point. The ending point can be static, or it can be dynamic like we've done here in the example. We want to take that starting point and we want to move it toward that ending point. While that starting point is still lower than the ending point or higher than the ending point if we're counting down, right? We're going to do something else. And in doing something else, we're also going to invoke the function inside of this condition. So that's going to jump it back up to the top of the function and have it start working again. When that starting value gets greater or lesser, depending on the situation, right? Then that ending value, then this condition will be false. So none of this code will run, meaning it will not recurse, meaning it will just skip here, and everything will be fine. And you're done. So that is all that I have for you for today. I'm going to turn on the music for just a couple more minutes. Hang out in chat just in case anybody who's here with me live has any questions. Thank you for watching, and we'll see you next time.